So here comes another important concept in design of digital IR filter, that is the frequency warping. So frequency warping is nothing but the conversion or transformation of from one form of frequency to another form of frequency, that is converting the analog frequency into digital frequency or digital frequency into the analog frequency. So that is known as the frequency warping, right? So here we have two relations which gives how to convert the one form of frequency into another form, right? So here I will pronounce this one as omega, and this omega is known as analog frequency, and this W is known as the digital frequency, right? If you know the digital frequency W, you can convert into analog frequency by using this equation 2 by T, where T is sampling interval. And how to convert the analog frequency into digital frequency by using this second equation. Understood? So this first equation is used to convert the digital frequency into analog frequency, and this second equation is used to convert the analog frequency into digital frequency, where T is the sampling interval or sampling period, right? So now let us discuss the design procedure of the digital IR filter, right? So we'll discuss the design procedure of the digital IR filter. So it is very simple. Design procedure of digital IR filter, very important for examination point of view, right? So first step is they will give the digital specifications. What are these digital specifications? The digital specifications could be the digital frequencies. What are digital frequency? Passband frequency WP, stop band frequency WS, passband gain KP, and stop band gain is KS. So these are the digital specifications for the filter, right? So in the first step you have to convert these digital specifications into the analog specifications, right? So digital specifications you have to convert into analog specifications, right? So how the analog specifications are given by omega P, that is passband frequency, omega stop band frequency, Kp is passband gain, and Ks is the stop band gain or stop band attenuation. So how to convert this digital specification to analog specifications? Mainly this analog digital frequency into analog frequency by using the frequency warping. So what is that frequency warping? It is nothing but converting the frequencies from one form to another form, either analog to digital or digital to analog. So here we have to convert digital specification to analog specification. So the omega is equal to which is 2 divided by T tan of W divided by 2, right? So if you want omega P, that is passband analog frequency, it is 2 by T tan of WP divided by 2. If you want a ws, then it is 2 divided by t tan of ws divided by 2. So this is the second step, right? So once you have omega p, omega s, kp and ks, the third step is what? To design the analog filter. To design the analog filter. So the design of analog filter is nothing but to determine the transfer function h of s from the, so it could be any low pass filter, high pass filter, or band pass filter, or band stop filter, right? So if it is low pass filter, then I will write so HLPS, right? So the design of analog filter is nothing but obtaining the transfer function in S domain using what? The normalized low pass filter or low pass prototype, which is having the transfer function h of s, right? So this is known as the low pass prototype, whose cutoff frequency, as we discussed in the yesterday class, whose cutoff frequency is always 1 radian per second, right? So if you want to convert the low pass prototype into low pass filter, so what is the substitution? You have to replace s by what? Yes, s divided by omega c, right? Where omega c is what? The cutoff frequency. If you want to convert the low pass prototype into high pass, what is the substitution? S is equal to omega c divided by s. If you want to convert the low pass prototype into band pass, what is the substitution? Substitution is what? S square plus omega naught square divided by s into w, where what is this omega naught? It is a center frequency, that is equal to square root of omega L into omega h, lower cutoff frequency and higher cutoff frequency. And what is this W? This is the passband bandwidth, which is given by WH minus WL. Similarly, for low pass prototype into band stop filter, the substitution was, it is 1 over this one, S into W, S square plus W naught square, right? So now, once you design analog filter, the last step is to what? Design of digital filter. So you know how to design a digital filter using analog filter, how to convert analog filter into a digital filter. So it is nothing but converting h of s to h of z, right? H of s, by substituting s is equal to, if you are using the bilinear transformation technique, what is the substitution? S is equal to t by 2 into z minus 1 divided by z plus 1, right? So in this, for example, h of s is equal to 1 divided by s plus 1, right? Substitute s by t by 2 z minus 1 and z plus 1, and they will give the t is equal to some value, substitute t also, and then simplify, you will get s of z is equal to like this one, right? So z divided by z square minus z plus 2, something like this. So this is nothing but the transfer function of digital filter, right? So determining the transfer function h of z is nothing but the design of the digital filter. Understood? So this is the simple procedure you have to follow to design the digital IR filter. Digital IR filter. So this is very important. Understood? So what is the first step? When the digital specifications are given like WP, WS, KP and KS, you have to convert into analog specification using concept known as the frequency warping. That is omega p is equal to this equation and omega s is equal to this equation, right? Depending upon the requirement. Then once you have the analog specification, make use of this analog specification to design an analog filter. The design of analog filter is nothing but obtaining its transfer function in S domain, that is h of s in general. Once you design analog filter, then you can easily design digital filter by using the bilinear transformation technique, where we use the substitution parameter as t by 2 into z minus 1 z minus 1 divided by z plus 1. Is that clear? Yes? Sorry, I have made one small mistake here. So this is not t by 2, it is 2 divided by t. Please make a note. It is 2 divided by t. Sorry for that. Right? So this is the actual simple procedure for design of any digital IR filter. Right? So in the next class we'll discuss one or two examples where we understand how to design the digital IR filter. Is that clear? Okay. Thank you.